Conditional probability sounds fancy, but on the SAT, and it usually means one practical move. Shrink the sample space to the group named in the given clause, then treat that group as your new 100%. After this video, you will read, given that like a cue to ignore the wrong rows, fix the denominator, and compute a clean fraction. We will connect the formal formula to tables, a medical test story, and a Bayes-style twist that still follows the same logic. Whenever you see a vertical bar, pause and translate it aloud. Given the right side, what fraction of that world satisfies the left side? The probability of a given B asks how likely A is if you already know B happened. In symbols, probability of A given B equals probability of A and B divided by probability of B when probability of B is not 0. Think of it as zooming in. You only measure inside the B world, so B becomes your new 100%. On most SAT problems, you will not need heavy algebra or symbolic manipulation. You will count cells in a table, read a tree carefully, or translate words into two clear fractions that already fit the definition. Easy path, a two-way table. Suppose 200 students total and 100 play sports. You want the probability a student plays music, given that the student plays sports. Restrict to the sports row. 40 students play music and sports out of 100 sports students. So the probability is 40 over 100, which simplifies to 2/5 or 0.4. Medium style, a medical test. Suppose 1% of people have a condition. A test is 99% accurate for positives among sick patients. You might be asked for the probability someone is sick. Given a positive test, that is not the same as the test accuracy number alone. You must restrict to the positive test group. That denominator mixes true positives and false positives. On the SAT, they usually give counts or a table so you can compute the fraction directly without memorizing Bayes formulas. Harder SAT framing. You know a joint probability and a marginal, and you must isolate a conditional. Remember the definition. Probability of a given B is probability of A and B divided by probability of B. If you are given counts, replace each probability by favorable over grand total, then simplify. If you accidentally swap A and B in the numerator, you are computing a different conditional. Read the wording twice. Common mistake. Confusing probability of a given B with probability of B given A. They are different fractions. Probability of sick given positive is not the same as probability of positive given sick. The denominators live in different groups. Another frequent slip is using the grand total in the denominator when the problem gives you a row total or column total instead. SAT pro tip: after you identify the given condition, restrict the sample space first. Count only inside that row or column. Your denominator should match the given group size, not necessarily the whole table total. Circle the row or column in your booklet if you can. That simple move prevents the classic 200 in the denominator error. Recap. First, probability of A given B is probability of A and B divided by probability of B. Second, on tables, shrink to the given row or column before you form your fraction. Third, never swap A and B unless the question explicitly asks for the reverse conditional, because swapping changes both the numerator story and the denominator universe. Practice more on NovaMaths.